Well, hello and welcome to this new video. This is not gonna be any tutorial video. It's just the update on what I've been doing, some exciting things I've been doing. I've just taken up Microsoft Azure Data Fundamentals certification from Azure Microsoft earlier this month, like about last week. Just want to share that update, how I prepare for this and why I decided to take this certification. So I literally prepared for like 5 to 6 hours for this certification. I was not familiar with Microsoft at all. I haven't worked with Azure that extensively. I've been working with AWS quite a lot, a little bit with Google Cloud Platform as well. I've created orchestrated pipelines on Google Cloud, been working extensively with AWS. So I just decided to take up on Azure, learn Azure, and be a truly become a multi-cloud specialist, especially big three cloud platforms. AWS has always been a big player in cloud platforms, but Azure is taking a second place in my opinion. It's going to replace Google Cloud in terms of popularity and there's a reason behind that, because every organization would have some Microsoft product in one way or the other, because they might be using Microsoft Teams, Office, or something else, and then they already have that Microsoft and they decide to either migrate their workloads on cloud or maybe use multi-cloud strategy alongside something like AWS and Azure, or maybe hybrid strategies as well. So a lot of companies are now adopting Azure as their main or secondary cloud platform. So that's why I just wanted to dive deep into Azure. So I just wanted to let you know the best resource to prepare for this certification is literally the Microsoft Learn platform. They do have, let me show you here, they do have a self-learning course literally named after Microsoft Azure Data Fundamental DP-900, and as you can see it has like 4 different modules and 2 to 3 modules in each, sub-modules in each those modules, and it's not gonna take a lot of time if you've worked with data majority of time in your career. If you are familiar with the database concepts, then you just need to make yourself familiar with the Azure, what Azure offers to deal with those database technologies. That's what this certification is all about. So I have prepared like a short I've noted down few notes for you guys. So this video is just about if you want to revise, if you are giving this certification exam, and if at the last moment if you just want to revise quickly everything, this video is for you. So let me show you the first thing that's discussed in that Microsoft course is the core data concept, what type of databases there are. So yeah, relational traditional databases, you have tables and normalization in those tables. Then on non-relational databases, you have column-based database, you have key value pair database, you have graph database, you have document type database like MongoDB, right? So these are the databases I've talked about briefly for each and every databases, and when to use what type of data they store and stuff like that. And there is a concept of OLTP and OLAP. Basically OLTP is transactional data processing, and OLAP is analytical data processing. For OLTP, basically is used for business application. It handles like high volumes of data, like for example bank transactions and e-commerce platform transactions, and it's optimized mainly for write functionality, you can say that. And on the other hand, OLAP is the analytical applications. It's used mostly for analytical application, and it deals with high volume of historical data, because you want to do analysis on the data that's already there in the database, right? And that's why it's optimized for read rather than write, and it's pre-aggregated, and that's why the read queries are really quick, and it reads the data from database really efficiently compared to the writing to the database. Then there are relational database. The ACID property, you should already know about this. ACID, A stands for atomicity. Each transaction is treated as a single unit. Either the transaction is successful or it's a total failure. It is, for example, if you are placing an order on Amazon, if the order is placed or the order is not placed, it's nothing in between. So that's the atomicity. The consistency, the transaction maintain the integrity of the database by ensuring the data is always in valid state and is available throughout the organization consistently. That's the consistency. And in the isolation, basically if there are multiple processes, multiple transactions are happening in the database, those transactions are not meant to be interfering with each other. That's what the isolation. Each transaction is isolated with the other ones. The durability, when transaction is committed, it stays committed. Once you place an order, it's placed. You cannot change that transaction. You cannot, once you have committed that to the database, you cannot change that. Of course, you need to make another transaction in order to cancel that order. That would be another transaction, not the same transaction. So once the transaction in terms of database transaction, once you have inserted, you cannot stop the insert into database query midway. It will insert. It will stay committed there. There are some more relational database concepts like normalization, having those multiple tables, having primary and foreign keys and joining those tables, that sort of normalization. Then there is three sorts of SQL data languages. DDL, definition language, that's mainly create, alter, drop, rename, whatever you whenever you want to create something in the database, you define a table, you define a procedure, you define something. That's what definition language is. Then there is control language. It deals mainly with permissions, like you grant permission, you deny permission, you revoke permission from someone. And then there is manipulation. If you want to manipulate the data in the database, like insert, update, delete, those sort of statements are considered manipulation. Then there are database objects. Remember, we are talking about relational databases. There is view, is basically a virtual table, a select query on the table. There is stored procedure, like if you want to run some sort of a logical statement inside a query, that's called the stored procedure. Then there is indexing. It makes sorting in the database. If you for example, here let me take back to this example. If this in this table, name, dry food and good boy, if you apply index to the name and let's say there are millions of records, it will sort those data out and it will search for that index only, and that's why it makes the searching of data much efficient in relational databases. Again, I'm just going over everything very briefly. I highly suggest you take that Microsoft Learn course if you're preparing for this exam. And the next one is Azure SQL Services. I've literally taken this screenshot because they have explained everything so beautifully here. There are SQL Server on VMs you can run, which is like infrastructure as a service. Then you have managed instances that run SQL servers, which is platform as a service. And there is another platform as a service, which is SQL Database. You can read about all those and the use cases and everything. But yeah, in short, if you are familiar with AWS, Azure SQL Database is basically equivalent to Amazon RDS. Managed instances is basically when you host your database on instances that are managed by cloud itself, so you don't deal with any sort of software patch or anything. You just deal with the database itself. The software patches and updates and backups and recovery will happen automatically because that's a managed instance. And if you run SQL Server on a virtual machine like an EC2 instance, which is not managed, you are responsible for literally everything. So that's the crux difference between those three services on Azure. And there are different non-relational database services on Azure, like blob storage. You like think of a container to group similar sort of blocks together. It has the hierarchy of the folders, just like you can think of OneDrive. It's concept-wise, it will be pretty similar. Then there are types of blobs as well. First of all is blob. They are the best used to store the discrete large binary objects that changes infrequently. Basically, they are not changing files, are stored as a blob. Not changing frequently files here. Then there is a page blob. It's this very small size of data blob, 512 bytes of pages, and it's best to use in the case of there is random read and write operations are involved. And there is append blob. It is, you can think of like an array append operations. You just literally add the data at the end of the block, and you cannot change that data, that blob afterwards. You cannot update or you cannot delete that data. That's what append blob is. And there is a service called Data Lake Storage Gen 2, which is again a hierarchy of storage for analytical data lake, and mainly is for big data. There is OneLake as well, which is pretty similar conceptually, but if you want to share a data lake in your organization between different teams, that's what you go for. There is Azure Files as well, which acts as a file share. It mainly deals with a couple of network protocols, server message block, SMB, and there is network file system for files, shared files storage. And there is Azure Table Service as well, which mainly deals with NoSQL storage with key value data types. And whenever there is key value, it's mean that is semi-structured data. The tables in this sort of storage have unique keys, the composition of partition and a row key, and it improves the stability and performance when searching the data. It includes the key of that partition key in that search, which helps to reduce the amount of IOPS used, and that's why it enhances the performance of those read queries. Then there is a service of Cosmos DB on Azure, which is equivalent to something like DynamoDB, but a lot more than DynamoDB, right? So it supports multiple APIs, like it uses index and partition keys to process a massive volume of data with better performance. And it does support multi-region writes as well. You might have heard of write and read instances in Amazon RDS. So usually there is only one write. You can have more, but only one write instance and multiple read instances. But in Cosmos DB, you can have multiple write instances and in multiple region as well, not only in one region. So that's something exciting that Cosmos DB offer. It's highly scalable and it's mainly used for everything. Think of IoT, retail, gaming, mobile and web, everything you can use Cosmos DB for. And there are multiple APIs, like for Microsoft's own NoSQL services that use NoSQL API of Cosmos DB. There is an API for MongoDB which deals with space and file binary JSON object files, and there is PostgreSQL API which is for distribution, which offers distributed Postgres optimization, and it automatically shards the data for high scalability and efficient processing of those data. Then there is API for table data, which deals with key value. Then API for Cassandra, column family data. Then there is a Gremlin API, which deals with the graph data type. Then there are services for real-time analytics. You think of batch processing, processing historical data in batches every hour or so, every day. It processes. It's like scheduling the task to process certain amount of data. That's what batch processing is. And that is stream processing. Think of the real-time data generation and processing those data in real time. The data stream processing, that's what it is. And the service for real-time analytics, on Azure, there are different services: Azure Stream Service, Platform as a Service, the Spark Structured Streaming, which is open source, and there is Microsoft Fabric, a new service in Azure. Then there is the sources. Where could this real-time data be generated from? Like there is Event Hub, IoT Hub. It can be Kafka, it can be data lake storage Gen 2, or any other data lake on Azure. So these are the main four sources that could be for streaming data on Azure. And there is data warehousing as well. So you think of ETL and ELT, extract, transform, and load. You extract the data from sources, then perhaps run some sort of a transformation on that data, and then eventually load those data into a warehousing, a data warehouse or a database. And there is a concept of ELT. You extract that, load that into a data lake, and then transform those data from data lake, and then eventually you will be loading that to a data warehouse. So that for data ingestion, that is a service for pipeline orchestration, which is Azure Data Factory. Azure Data Factory basically uses the linked service to load and process data. Every service is like, if you want to copy data, if you want to run some sort of a transformation, you can orchestrate that pipeline in Azure Data Factory, and it will use in the background something called linked services. And if you want to run everything at one place, data ingestion, transformation, data analytics, data warehouse, data lake, basically everything related to data, if you want to have everything at one place, there is a new platform called Microsoft Fabric, which is I'm really excited to learn. I am learning about it. I'm also preparing to give a Fabric data engineering examination as well, a new certification. Then what data warehouses is basically a relational database which is optimized for analytical workloads. And while creating those relational databases, you keep the two types of schema in mind. Star schema, basically it involves fact tables and dimensional. For example, in this image, the central table would be a fact table which will store the facts about the business, like how many sales happened, like and the metadata of those facts would be stored in the joint table to that fact table, which are called dimensional table. And if you further normalize those tables, it will be called as Snowflake schema. So keep those in mind, star schema and Snowflake schema. And I believe the analytical platform, which I haven't included in this PPT, there is an analytical platform of Power BI that Microsoft offers. Basically, it allows you to create dashboards, reports, and share those dashboards on with different users. Public those dashboards on internet and stuff like that. You can have multiple types of charts like pie chart, bar charts, line chart, scattered chart to display a different relationship between the data. So I believe that would be just that. You don't need to prepare for anything else for this examination. DP-900, Microsoft Data, Azure Data Fundamentals. So I highly encourage you, go for this, and yeah, it will be something good to show on LinkedIn profile, perhaps on your resume, if you're aiming to get into data engineering and cloud. It will be an evidence that you are familiar with the cloud and data concept. So yeah, I highly encourage you. I just got that like in like 5 to 6 hours of preparation, so it's not that hard. It'll be easier for you if you have been working in the industry for a long period of time. So yeah, I think that's it for this video. I'll see you guys in the next video with more updates. Thanks.